Hi everyone, we're going to talk about the parent function, which is the cubic root function. Okay, and we're going to fill out all this information. These two are where y is positive and negative. These two we're going to talk about in behavior of the function, in behavior, and the symmetry, and these two go together. So you need to have these written down because I'm going to just kind of talk about them all at once. Basically, let me do the table of values here. I'm going to pick a good table of values. So I'm going to do cubes. So I'm going to do a -8. Cube root of -8 is -2. And the cube root of -1 is -1. And then cube root of 1 is 1. And cube root of 8 is 2. Alright? If you look at this, our domain can be all real numbers. I just picked these values to help me graph. And my range can also be all real numbers. So basically the domain is all real numbers. And the range is all real numbers. Alright, let's look at it. I went ahead and graphed it here based on the table. And what we want to talk about, where is y positive? Y is positive in quadrant 1 in this case, which is so y is positive where x starts at 0, can't equal it, and goes to infinity. Y is negative in this quadrant 3, so y is negative from negative infinity to 0. We're just talking about this part here is just talking about your x values. So that's your x values here. Now, as far as in behavior, how we're going to write that is we're looking at the arrows here. So y approaches infinity here as x approaches infinity. Or it means infinity just means as x gets bigger and bigger. Okay, and then y here is going to negative infinity as x approaches negative infinity. And that's all in behavior is. All right? Is this function one-to-one? Yes. Because it passes the horizontal line test. It doesn't hit twice. That means we don't have to restrict the domain for the inverses. It's also symmetric about the origin because you can reflect this over the x and the y about the origin. So it's that symmetry is about the origin. That means it's odd. It's an odd function. So they both start with O's. Okay. We have to find the inverse. To find the inverse, all we're going to do is, let me go ahead and write my f function. We went -8, -1, 0, 0, 1, 1. +8 goes to 2. So, to do the inverse, you just switch the x and the y. So it's -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. So basically, the inverse is actually y equals x cubed. Okay, this was y equals cube root of x. So they're inverses of each other. So if I draw my cube root function, 1, 2, 3, 4, 5, 6, 7, 8. 8 goes to 2. So if I draw this, 1, 2, 3, 4, 5, 6, 7, 8. So that's the cube root function. Again, it's hard to draw on here. All right, the cube function, if I graph that, is going to be this. 2 goes to 8. And we already graphed this in a previous video. Okay, so this is the inverse. All right, and you should notice that this reflects over the y equals x. Okay, and we didn't have to restrict it because it was a one-to-one function. Okay, the next thing we're going to do is the transformations, and the form is y equals cube root of x minus h plus k. So I'm going to go ahead and graph I'm just going to go down, this is about 8. I'm just estimating here because I want to go a little faster, which I shouldn't do because then I mess up. All right, that's what happens when you go too fast. Okay, so there's your cube, your parent function. So what I want to do first is shift this to the right by 2. And all I'm going to do is take these key points, move my origin by 2, move this by 2, and move this over by 2. And so this gets moved over by 2. And this gets moved over by 2. Right here, sorry. So basically, it's like this. The whole thing just got shifted over by 2 units. All right. This does not look good. All right. I don't like this at all. Okay, so basically, let me graph this properly. So I'm going to erase this. I'm just going to shift the whole thing over by 2. So I'm going to go over by 2, go down 1, and then go 1, 2, 3, 4, 5, 6, 7, 8, goes to 2, 1, 2. Okay, so this is the center. So that goes there, goes down here, and it goes like that. All right, so I just shifted the whole thing over by 2. And now the next one I want to do is to shift this up by 2. So I'm going to take my parent function, which was here, and go up by 2. So I'm going to start here, go 1, go down 1, and then at 8, we're going up 2. 8, we're going up 2. So something like this. Again, if you have graph paper, you can make this better. So this is the vertical shift. The green is the vertical shift up by 2. And the red is the horizontal shift to the right by 2. And that's all. The next one we're going to do is the quartic function. Thank you and have a nice day. Bye-bye.